The universe is made up of oceans, called quantum fields, and tiny disturbances in these oceans are what give you particles. You know, the quarks and leptons that form the fundamental particles of nature, making up everything in the universe. Yeah, those little insignificant things. In total, including bosons, the fields can produce a total of 17 elementary particles. Each of these has a different mass and thus combine to form different things. But have you ever wondered, where does this mass actually come from? All this I just told you was proposed by Paul Dirac in the quantum field theory. Theorized in the 1920s, it worked well, except no one knew where the mass for the particles actually came from. Well, the answer is the Higgs field. Formulated in the 1960s and named after Peter Higgs, the first evidences of the Higgs field was found in the CERN laboratory in 2012 with the observation of the Higgs boson. So, how does this work then? The Higgs field is a mass giving field, and particle interactions with this field are what give the particles their mass. Think of it like going into a party with a famous celebrity. As you walk in, obviously the people are gonna crowd around the celebrity, and he will have a hard time getting to the other side of the party, whereas you will move through it undisturbed. The Higgs field mostly works like this. You represent a particle that doesn't interact with the field and is thus massless, like a photon, and travel at the speed of light, whereas the celebrity represents a particle with mass. But where does the Higgs boson fit into this? Well, the Higgs boson is an excitation in the Higgs field. It's an indication that the field exists. Let's take a simple example. The water in the glass here is the Higgs field, and the pebble is the particle. When the particle hits the water, the splash created is the Higgs boson. As the particle gains mass, the Higgs field experiences excitations, and these excitations are called the Higgs boson. But it is to be remembered that the particles that gain mass and the ones that remain massless are the one and the same before they enter the field. It is just their interactions with them that determine how the particles will turn out to. So that's it. That's the basics of the Higgs field. Although this is just an analogy, it offers a simpler way to understand all of this. This is an emerging concept in science today and will require a lot more complex mathematics to solve. But alas, that is the process with everything. And one day, this concept might help us understand some of the universe's grandest secrets. Thank you for watching.